In this video, you will discover how the ANSYS SCADE family supports the AUTOSAR standard. AUTOSAR is a standard that's gaining momentum worldwide, and which promotes the standardization of automotive embedded software, electric and electronic components. AUTOSAR's objectives are modularity and configurability. It defines a layered software architecture, allowing integration on electronic control units with configurability, and it enables function reuse from different suppliers. Standardized interfaces are defined between each layer, and standardized data types are defined. All entities connected to this AUTOSAR runtime environment must comply to the AUTOSAR specification to ensure integration of the user-specific software. The AUTOSAR architecture consists of software components for the application, basic software components for low-level services, and a runtime environment. The ANSYS SCADE tools are used to design the software components that are the application parts. From the model in SCADE, code can be generated in compliance with the AUTOSAR required interfaces. The flow with SCADE is as follows. It starts with the AUTOSAR application description for the software components to be implemented. The AUTOSAR model is imported into SCADE Architect, in which additional information related to the implementation can be added. Runnables are parts of the model that will be the running software. They are synchronized with SCADE Suite. As the synchronization is bidirectional, it ensures full consistency between the architecture and implementation interfaces. The model behavior is designed in SCADE Suite, and the certified code is produced. Using that code and additional architecture level information, the AUTOSAR compliant code is generated. We will now illustrate this flow here. Let's start our demo with an example of a cruise control. This example is given as an AR XML file. We will use AR Top to quickly explain the model. AR Top is a tool available to all AUTOSAR members. Here we have a composition component, which is the root of our application. It is composed of a mode monitoring component and a regulation component, this one including two runnables. We will import the AUTOSAR model with SCADE Architect. So let's create a new project. We select a folder location and give a name to the project. You can see that the project is empty. We will import the model from the previous chapter. So let's select the AR XML file. We do the import from the settings. This is faster. We now have the same architecture with the same components. Let's add an internal block diagram, because so far we only have blocks but no diagrams. The AUTOSAR palette allows us to insert AUTOSAR elements. The palette is quite complete. Let's start our design. We add the blocks. We can choose what to show on our designs. We can display or hide elements. We can do this for already existing elements, for block interfaces, and existing links. It's therefore pretty easy to start from a description and initiate the graphics. As you see, everything is flexible for a better efficiency. Here's an example of the final result on the mode monitoring component, with all the internal blocks and even some colors. Let's take the AUTOSAR model. We will now export it into SCADE Suite Project. We will select first the new project for the export. We use the cruise control and then select which elements we want to translate, such as the needed types and the regulation elements. We can skip the ones not related to SCADE Suite. We now launch the exportation, set the settings, and launch it. In SCADE Suite, here's the new project. Let's have a look. This new project has exported exactly the same operators from the runnable with exactly the same variables. We can find the same interfaces with the proper types. So the import was produced as expected. Now we will go for some implementation. I created a more complex project. We have this AUTOSAR and car models, and an already existing implementation of the cruise control with speed regulation mode monitoring made of these equations. Let's take the exported model and paste it into the existing operators. Let's see how SCADE Suite enables simulation with the connected cruise control and the car model. We launch the simulation and the graphical panel. We have a completed operational cruise control model with which we can play. The simulation looks correct. Let's go to the next step. We will now generate code from our model. Using the Settings panel, we select the 3 top-level operators and set AUTOSAR as target. We launch the code generation. Here are the results, with all the files generated with the components as C behavior, and the AUTOSAR-related files with dedicated header files and the adaptation code. The instantiation of AUTOSAR methodology is therefore first to get the software component's description into SCADE Architect, to refine it and perform consistency checks, then to design the runnable behavior while ensuring consistency between software architecture and design, and generates AUTOSAR and ISO 26262 compliant code, and finally, get the generated code and build the final application. For more information, please visit our website at www.ansys.com. There you'll find more detail about our model-based engineering solutions for automotive, model-based systems and software engineering, 3D physical simulation, PIL and HIL solutions, and full virtual simulation mixing multiphysics and embedded software while fulfilling ISO 26262 requirements. Thank you.